Welcome back to Project Brupeg, the story of a sunken fishing trawler converting to a global expedition boat. Before we get stuck into our crash bulkhead today and doing the steelwork up the front there, we're going to take a little bit of time and get the first layer of insulation done in our lounge. It's hitting 40 degrees Celsius on some days in Aussie, and it's only the start of December, so we've got 3 more months of dealing with that sort of temperature. We've got 60mm polystyrene that we basically jam in, and these beams here are 50mm tall, so we're jamming a 60mm piece into a 50mm slot. Hence we need to use a fair bit of force to whack those in, but keeps it really nice and tightly pressed up against the roof, so it works really well for what we're trying to achieve.
Dame also got a chance to get on with a little bit of the keel. He cut it open to check what the concrete inside the keel and the steel looks like. Looked really great, and now we've got to close it back up. After prepping the area, Dame had a go at welding, but we've been having problems with the welder, so Dame's going to take it into the shop. We just couldn't carry on with the job.
So we're just getting started for the day, and you can see we've got tarps or shade cloth hanging all over the front of the boat. We're not in the sun at the moment, but it's supposed to be stinking hot, high 30s Celsius. So what we're doing, we've chopped into the tank, we've chopped the side out, we've also chopped the floor out of the anchor room. Might be a bit hard to see in the light, but all of that's gone. So what we're going to do is start basically cut our way in and weld our way back out. That was a comment that I loved from one of our viewers. This is what we've replaced. So gives you an idea. This is the side of the boat. You can sort of see there's a lot of rust basically all over the repair panel, but also on the actual steel of the hull itself. And then over on this guy here, that's the bulkhead that you're seeing there. So the bulkhead joined like that. Right, so what you've got down here, it should be 6mm thick or 1/4 inch, so it's probably 3mm there, maybe 2mm there. All the way up here is probably 2 to 3mm, so it's pretty thin by the time we got to the actual cutting it up. Over here it's still 6mm. You can see it's quite thick through where we've cut it, but up here it's wafer thin. It's probably 1mm. In this case it's gone through, so probably only less than 1/2 mm thick over here, so tiny piece of steel left. It's worn away over in here. You can sort of see it dimples down like that. Same deal over the back here. Dimples down a lot through here. It's probably maybe 1mm thick over this area. Yeah, because that really helped, Damien. So down over here, probably got less than 1mm. It's gone through here. You can sort of, the sand's in the way, but you can sort of see it's gone through just in there. Still over in here, it's probably less than 1mm. So this whole area was majorly compromised. Now, these are the verticals that we cut out. So these used to weld in sort of like that. Maybe that's the other. Maybe that's the one that goes in there. I don't know, one of them, doesn't really matter. Goes in like that basically is how it welded in. But you can sort of see, look at that. It's actually rusted through to nothing. So there's literally nothing on the end, and that gives you an idea of what it should have been. And then you look down there, wafer thin. So you can bloody near shave with that. Up here, pretty thin as well, so it's maybe a couple of mil thick right up at the top. So all of this steel work, here's a piece that came out of the side of the boat. You can sort of see that, like, all of it was basically cactus. Now, a number of people have asked, does that mean the boat has catastrophic rust damage? No, this is really, really normal in commercial boats. So in a commercial boat, if they were faced with this, they would just do exactly what we've done, cut a hole in the side and weld new steel in. I've seen a boat come in here maybe 12, 18 months ago, and they pretty much cut the entire bow off from the front, that bulkhead going all the way down there where we've cut to. they pretty much cut from there forward off right to the deck, and they replaced the whole thing with stainless. So you could, when they pulled it in on the travel lift, you could see through it. It looked like mesh. You could see from one side of the bow to the other. So in the commercial world, it's stock standard to basically just cut out the old stuff and put in new stuff and then carry on for another 15 years of service. In the recreational boating world, that's obviously nowhere near as normal, but yeah, this sort of stuff is normal in our world. So some people have asked us, does that mean that Brupeg has rust like this from going underwater? The answer is no. So this rust is old rust. It's been there for probably 5, maybe 10 years. It's rust that happens when you neglect part of the hull. And the reason why they would have neglected it is because it's a sealed tank welded in underneath the floor. The only way to get there is to literally cut the boat open like we've done. So it's not something that you do every year. You might do it every 5 years, but they haul out every 5 years to do survey requirement checks. And they might have done it every 5 years as part of that, I'm not sure, but it's something that's been going on for a while. Normally you can leave a tank unpainted, a mild steel tank can be left unpainted, and you just seal it up, and if there's no fresh oxygen getting in, it'll rust a little bit on the surface, but it will stop rusting as soon as the oxygen's all used up. In this case, the tank obviously had a leak, so oxygen could keep getting in, and the rust could carry on. So this has nothing to do with going underwater. This is 100% to do with lack of maintenance over a period of say 5 to 10 years. We're going to put these plates in, we're going to measure them up to make sure that they're going to fit, and to do that we're just going to weld on a big handle so that we can just go make life easy when we're putting them in and out. Trev's over the back, he's cutting up probably half a dozen little short lengths. You can sort of see about 2 inches long. We do a whole bunch of them like that, and what that allows us to do is to weld them around the edge of these plates so that when we put them in we know it's flush against the plate beside it. As we've discussed previously, it's important to weld when it's windiest. Really helps you to improve your welding, get the best results. Oh yeah, listen to the porosity. That'll do.
This stuff here to stand on?
Nah, just clear it out. So we've got our piece of plate that's going in the bulkhead, and we've welded on some tags, so you can sort of see they're just basically sticking out. These are the ones that Trev cut earlier, and by sticking them like this it means that we can get this piece flush with the steel beside it. So let's put it in place and show you how they work. So we've got our shape, so what we need to do now is all the way around these edges, we need to V them off. So I'll draw a little pattern to show you how we're going to weld these in. So for the non-welders in the room, basically when we go and create two pieces of steel, we've got one piece there, another piece there. We have to join them together. So this could be one part of the hull, and this could be a plate that we're putting in. this join here is critical. It has to be really good. So rather than just basically do like square ends on both of these plates and then try and fill it up with weld, that wouldn't be strong enough. You'd get cracks, you'd get leaks, you'd get all sorts of carry on. So the way that we do it is we bring the plates along, we do a 45-degree angle, a 45 on the other side. So we're left with a little flat bit in the middle here, and then a 45 top and bottom. You do exactly the same on this one here. So you come down like that, 45, and then back. So you end up with that shape with the two plates not touching, but very close together, with this shape on both pieces of steel. And what that allows is you do a little weld in the middle there, called a root weld, and then you V this out. So you get the grinder back in there, and you V out that side there like that, and that side there like that. So the root weld doesn't provide any strength or anything like that. All its job is to stop any further welds from sinking in through the other side of the metal. And it holds the plates together, so everything's held ready to go. There's no tacking at this point. Everything's welded up all the way around with that root weld. So once that's done, you've V'd it out with your grinder, then you go and do a capping weld, which is a nice big weld like that, and it fills it up like in a big sort of segment of a circle, if that makes sense. You got one there, and then the big cap goes on it. So on both sides of the steel you end up with this lump. Let me show you what this looks like in practice. So this is a plate that we welded in the engine bay. So it's probably about 1.5 meters square. And if you have a look at these welds, let me get right up into them. So this is what a nice capping weld looks like. All the way along, nice and steady, uniform shape. I'll see if I can zoom right in to really show you the structure of it. So there you go, you can see really crystal clear weld. So there's a lot of rust, surface rust on this. That's okay, we'll blast that and paint it shortly. But yeah, basically lovely bead of weld all the way down, and it's exactly the same on the other side. So on the inside of the engine room where this plate is, there's a bead that looks exactly the same on the other side. So before we close in these holes on the side of the boat here, we need to figure out how bad is the rust on the other side. So over on this corner here, we've got the rust that we blasted out the other day. So we need to basically do essentially depth readings of how much metal has left the boat. We need to know if it's more than 1 millimeter, then it really does need to be replaced. It has to be as strong as we can get up here. So the plan is to go through and do some readings and see how much we're working with. So time to get serious. My pal from Dangar Marine, Stu, he lent me his ultrasound kit. We're going to get stuck in and start ultrasounding how thick this steel is. We'll just do somewhere in there. Somewhere in there. So at 2 mil, maybe it is 4 mil, I don't know. 4.3, 5.6. There's the worst. 4.8. So we've got 6 mil here roughly.
6.1. Yeah.
Alright, so we're accurate, 6.1. Yeah, it's pretty good. Let's check some of this stuff on the side over here.
5.5.
5.5, yeah. I mean, that's the worst bit. 5.8. 5.7, 5.8. I'm happy with that. That's not so bad, eh? So Stewie's magical ultrasound. At the moment, basically what we're finding, so this is the end that you have to use. So it's, I don't know, probably 3/8 of an inch, 10 mil, something like that across. This is the face that goes on the steel. So you push it down like that onto the steel. What we're finding is if the steel's flat, we can get a really lovely accurate reading within 0.1 of a millimeter. If the steel is dimpled, this thing here is too big to go in the dimples and get an accurate reading. So on 6 mil steel, we're getting readings like 7 millimeters, 7.2 mil. There you go, that was the last reading we got off a piece that had corrosion in it. So we're not, the manual does say that it'll sometimes give you twice the thickness as it's reading because of the way that the sound waves bounce around inside the metal. So halve that, and that's potentially what the thickness of the metal is. Or the other thought is it's not getting a good enough contact and therefore it's being a bit silly. So we don't know. Either way, we don't have enough faith to trust the numbers we're getting, so we're just going to go back to the ichrometer We're going to start welding where we believe we can save it with pad welding, and then we're going to just cut and replace where we have to replace the actual steel itself. We've come up with a slightly new plan. We're going to be testing from the outside to see if it works. So Trev's basically, we've got some corrosion down the bottom there that Trev's trying to line up with his ultrasound machine. Yeah, about there. So, yeah, what do we got? 5.95, 6, probably pretty close.
That's just there, I reckon.
Yeah, it's not real corroded there, so it's probably pretty accurate. We need to find somewhere where we've got some real bad corrosion. What about up here, where we've got that real thin bit? Down, yeah, just there, that's it, yeah. .5, 3.6. Probably halve that and I reckon you're safe. I don't think it's 3 mil.
What's that?
I got 6 mil.
That's just there.
Yeah, so that's probably accurate. Alright, so I think that might have solved it. I reckon we know how to do it now. So Trev's on the outside of the boat at the moment, just doing some checks to see if we can figure out the measurements going the opposite direction. Still don't have full confidence that we're going to get like absolute precision, that we know how thick that metal is. Another way we could do it, a manual way, is actually just drill a hole through the thinnest bit and see how thick the steel is that's left there. So it's way too windy. Look at the background. We can't weld in this, so we're going to be doing some tack welding. We don't necessarily need to have perfect welds for tacks and things like that. We're just going to be hooking the plates in with a bit of tack welding so that they can stay there, so that when the wind does drop, we can get in there properly and start welding them in. Now that we're giving everything time to dry off, so we're going to start pad welding over in those far corners. Basically, we're going to fill up the metal and actually start building the thickness up. This is something that you can do in certain situations. So the metal over there is not really that corroded. It looks bad, but it's only gone down a couple of mil. It started off as 6 and it's down to 3.5. So what have we lost? 2.5 millimeters of corrosion has happened. So we can easily build that back up without compromising the steel, and we'll build it back up so that it's more than 6 millimeters thick. So theoretically, it's going to be stronger than the original. This is something you can do where you've got minor pitting and not large areas of panel loss. Over on this side where we have where we cut the hole, there's no way we could have done that. The corrosion was just far too bad for that.
Comes with a 10-year warranty.
So we're starting to get the plates in, so this one's fitting now. So there's a few gaps we need to fill up with weld, a wee bit further than we would have hoped, but that's all good. This one here, you can see the top, the corner's not quite fitting, it needs to be pressed in. When you look at it that way, it fits quite well. It's a wee bit hard to tell, but it's pretty close that way. But this way, you can see it's sticking out quite a bit, so there's a bit of a bend on this bulkhead, so that's all good. We can easily deal with that through our lever trick that we often use. Now, we need to start filling. I can't show you that because it's just too bright, but we need to start filling that up. So we're going to make sure all the edges are sorted, which they are, and we're going to get this plate in now.
Go! It's gonna get dark.
How's that? Can I mark that?
The bottom right hand corner.
Bottom right hand corner. Yep. So you got a little bit there,
Yeah.
and then you got your marks there. So with a fair bit of the pad welding done, you can see over the back, we've beefed up all of the areas that were a wee bit thin we weren't happy with. So what we're going to do now is go through and sandblast that and just basically take off the top surface so that it's fairly uniform. We're going to get a decent bond with the paint, but also so that I can have a real good look, so that it's all one colour and I can really get in there and confirm that I have in fact got the thin bits and I've beefed them up enough. This is basically what we're left with. So it's a surface that's been roughed up by sand, and it's really great for paint to be able to hold on. If you're going to paint a steel boat, you really do need to sandblast it so you get that nice key that the paint can hold onto. A lot of people freak out when it comes to wet sandblasting. It's something, it's a hate it or love it or hate it type thing. We find it incredibly helpful because we can sandblast and have zero dust, so it's really good for inside tanks and things like that. You do need to prep the paint differently, prep the steel, differently before you paint it. But apart from that, it's completely doable, and you can get just as long a finish as if you dry blast. Now that we've got the pad welds done, blasted off, and the plates blasted back, we've gone through and have a look at the pad welds. I'm pretty happy with those. We've covered up everything, it's nice and thick. Now it's time to start welding in that bulkhead plate for the front of the fuel tank. Is that as much as you got? Okay, here we go, welding. Okay, right? Tank. So back on board, we're about to climb into the tank. God, the boat feels so empty without little Mish here. Trev's here helping, and Jess is here. Hello, darling.
Hello.
What are you making?
Roast macadamias and Brazil nuts, and we're doing some fruit and some biscuits and a coffee.
Yummy.
Guilty.
Got our welder ready to go. We're about to climb down into the hole, get into the tank, and start welding that plate from the other side. If you're ever wondering what it takes to get some of these shots that we do in tanks and all of the confined spaces, I thought I'd show you this because it's kind of ridiculous. This is our setup for going in the tank. So we've got Danger Cam 1, Danger Cam 2, that's set up on a little clippy brackety thing, and it has its own light so we can illuminate, because GoPros aren't real crash hot when it comes to low light situation. We have a this is a rechargeable light bar, so we can magnetic base, we can stick that on anywhere in the tank, and then we've got a 240 volt work light. So and we have over the back, we have our one of our wide angle cameras, that's a Canon 80D. So all of that stuff needs to come in the tank with me when I start welding. Set some stuff up. So this is my office. That noise you can hear, the vacuum cleaner extracting all of the air from the bottom of the tank. Up the top, we've got danger cam 1 and the lighting rig. Far side there, you can see there's a light right up in the corner. We've got the close-up camera, and then we've got danger cam 2, and then up the front, set the light up there, and that allows come back. That whole front end is lit up nicely so you can see what I'm about to do. So now that we've gone through and welded from the other side, you can see the welds come through on this side a wee bit. We need to basically grind this all up. So down over here you can see it hasn't quite penetrated through because it's a wee bit tight on that side compared to the top. The top is quite open. But then all the way around sort of this edge, you can see that right the way down. So what the plan is now, we're going to go through the grinder and V all of that right out nice and deep. So we'll go right into probably 4 or 5 mil down from the surface, and then we'll fill the whole thing back up with a nice big capping weld. Gone through and welded. The welder's still running a bit crap, not real happy with how it's running, but we've gone through and we've been pretty robust with our welds. Some of them are significantly bigger than they needed to be, like right the way up this edge of the hull. It's a bit hard to see because of this angle, but we've done 3 runs over a lot of it, so it's pretty robust, and it's got the welding on the other side, so it'll be more than strong enough. We just need to get in there and make sure that we've got no leaks. packing up for the day. You can sort of see how much wind we've got going on. It's pretty near impossible to weld in this sort of weather. But what we managed to get done, we've got the bulkhead welded in and we've got this side of the hull welded in. So it's a tack on this side at this stage, on the outside of this hull. What we're going to do now is go inside and we'll start welding around that rim, and then come on the outside here again and we'll V out the weld that we've just put into it from the other side, and then we'll fill this side up. But we will probably weld this first thing in the morning when there's next to no wind.
But that's for next week. And Damien and Trevor got on to cutting up the jet ski. This is the engine that we'll be using for our jet dinghy.